So in this section, we talk about climate the way that it is seen from a sort of international cooperation perspective, right? The global side of the issue. Multiple countries, even hundreds of countries, who are working together, which is a necessity because everybody shares the same atmosphere and emissions from one country are going to impact all of the others. It's really hard to overemphasize just how differently positioned different nations are on this. Like what? Okay, so you could start with the United States, right? Wealthy country, totally industrialized, is currently in the process of switching a lot of its energy generation over to cleaner, more renewable sources. We do a whole unit on alternative energy later on, so I'm going to leave that discussion short for now, right? But you can compare that to India, just as an example. From the standpoint of an individual person in India, there is a direct relationship between the amount that you emit in terms of carbon dioxide and your quality of life. To put it another way, and this is what's happening, for China and India as countries, there's basically no faster way for them to improve the quality of life of their citizens than to build coal-fired power plants as far as the eye can see, or other fossil fuel power plants as far as the eye can see. And that's exactly what they're doing, and their citizens have experienced a tremendous improvement in the quality of life as a result. The question kind of at the heart of this as a global issue tends to be, who is going to pay for those developing, industrializing countries to develop clean energy? And I don't have an answer for you because neither does anyone else on that one. Awesome. We'll rewind a little bit, right? So back in that first section, we talk about the mechanics behind climate change, right? Greenhouse gases and the greenhouse effect, and how increases in carbon dioxide emissions as a result of industry can amplify that and lead to an increase in temperatures around the entire globe. Despite the fact that that is not well understood in all of its details and mechanics and bare bones by the vast majority of people, there were folks who had figured it out a long time ago. Like who? So, put some context in here, right? So, 1776, we have the development of a steam engine that is as good a starting point as any for kicking off the Industrial Revolution. Here, we have this person, Arrhenius, who you might have heard of if you took a chemistry class. He was actually a chemist by trade, had some incredibly influential works there. There are entire models of how, like, acids and bases react, which are based on his modeling. And he had figured out and crunched some numbers in 1896 and gone through essentially the calculations that I had laid out in the mechanics section and in our previous section on air pollution, and found that CO2 as a result of industrial activity was warming the atmosphere, and that it would continue to warm the atmosphere, and how much. In other words, climate change was known to extremely knowledgeable, technically literate, scientifically literate individuals for a long time, right? And as this kind of illustrates, right, climate change was figured out at least by one person closer to the start of the Industrial Revolution than to the present day. But this was not widespread. There were some other developments along the way that I'm kind of shortcutting here, right? But environmental issues in general, in the modern sense, didn't really take on their modern form, weren't really broadly seen as being, important and stuff that mattered until about the 1970s. You have Clean Air Act, 1970 in the United States, Clean Water Act, about 1970 in the United States. Have this conference in Stockholm in Sweden, which is essentially considered to be the birth of the modern environmental movement, right? This is not necessarily the first time that climate change was considered to be important, though, on the entire global stage. That didn't happen until about 15 years later, and it was related to this driving force behind fixing the ozone layer, right? The Montreal Protocol of 1987 banned these things called CFCs, or chlorofluorocarbons, which were used in manufacturing of all sorts of things, and which totally destroy the ozone layer. So as a result of this agreement between countries spurred on by scientists and policymakers, right, there was an agreement that nobody is going to use CFCs anymore. Ozone layer starts to recover, especially the ozone hole that was over Antarctica, starts to recover, and this is maybe the most spectacular success of environmental action taking ever. It also raises awareness of climate change at about the same time. So this might be the point where we could say that it is widespread, at least in a sort of global international sense, right, where climate change is commonly talked about. The IPCC, which we might remember I mentioned as being maybe the golden source on all of this. If you want to fact check anything I say, double check any part of it, cut me out, please. Go read the report, look for yourself, don't just take my word for it. They formed in about 1988. So this is the UN Environmental Program, part of the World Meteorological Association, right? Starts to publish these reports about climate change. They become much more sophisticated, much bigger, much more technical backbone to them over time, until the modern day full report, not just the summary for policymakers, but like the whole thing, is hundreds of countries, tens of thousands of scientists working together to be able to compile the best possible, most robust, best knowledge on climate, right? Kyoto 1995 is going to be a climate conference. It was important, but what we really want to spend some time on is Paris in 2015. Maybe something that we have heard about, the so-called Paris Climate Accords. So this was an agreement by about 200 countries in the entire world to come together and set emissions targets for themselves to try to keep the total amount of warming for the entire globe down below 1.5 C. Now, this is impossible. We are essentially already at 1.4. 2C is a possible but extreme target, and we sort of go downhill from there. But importantly for the Paris Climate Accords, right? The countries set their own targets about every 5 years and monitor their own progress. And there is no enforcement mechanism as part of it. So if you go and look this issue up, there are a lot of ways that people say that this was, legally binding, but there is no teeth to this agreement whatsoever. In other words, there is no enforcement mechanism, there is no cost to be paid if the countries don't meet up to what they said they were going to do. The United States is the only country to have left the Paris Climate Accords, which it did in 2017, then rejoined in 2021. This is ultimately somewhat of a toothless agreement, and yet it was the best we did, to kind of sum it up. Okay, emissions by country, right? So, I hate to ask the question of whose fault it is, but at some point you have to talk about, okay, whose fault it is. So, importantly, this is cumulative CO2 emissions since 1850, right? Maybe the start of our industrial era. This is different from the question of who is emitting the most carbon dioxide right now. Carbon dioxide lives in the atmosphere for a long time, like hundreds of years or even more. So these cumulative emissions are what matters when it comes to figuring out who is responsible for heating the entire globe, not just the emissions year by year by year. And as we will see, the United States, right, in terms of year-over-year emissions is now much lower than China, but in terms of cumulative emissions is top of the list. It is very much expected, and we can kind of count on it, that China will get to about here, right, and sort of match the US when all is said and done. That's really more than anybody knows, but it's what we should expect. And then everybody else is distant here. We'll notice where these come from for the most part, right, is energy and making cement, like for construction. A little bit, maybe, well, depending on where you are, right, for these more industrialized, more powerful countries, it comes from land use, agriculture, forestry. For less developed countries, right, Brazil, Indonesia, which are not wealthy powerhouses like the United States, tends to be a much bigger fraction of it, and not the use of fossil fuels, because their energy systems are just not as powerful or developed. In terms of which industries are going to be contributing, it is unfortunately a messy, complicated picture, right? So, as we saw here, right, fossil fuels, cement, land use are going to be the first things that should come to mind, right? So production of electricity and heat, agriculture, right? Emissions from cows, from deforestation, from other land use, transportation, right? Tailpipe emissions from cars and everything that's required to create them, constructing cement for buildings, other industrial processes which release CO2 as a byproduct, which is a lot of them. We're not going to dig into the full details of what should be done. That's going to come when we do alternative energy. But the point here is that it comes from many different places. So there is no necessarily silver bullet. Instead, each of these needs to change and develop. Now, working on electricity and heat production would have the biggest effect, but emissions are spread out among many sectors. No one of them individually is responsible for all of climate change or greenhouse gas emissions. In other words, as much as we might want to pick out a single boogeyman and say that it's, entirely the fault of the cars, it's entirely the fault of, cows and agriculture, it's entirely the fault of whoever, that is simply impossible. There has to be essentially a full-scale transformation and decarbonization of these sectors in order to get anywhere near where we eventually need to go, which is down to zero, right? Or less. Awesome. Now, we touched on this a little bit, right? Methane and CO2 are both greenhouse gases, but they affect the atmosphere in different ways. So CO2 has a much greater longevity in the atmosphere, but methane is much more potent, right? So 1 kilogram of methane is equal to about 23 kilograms of carbon dioxide. Figures on this run all the way up to 100, maybe 25 or 30 is the most common figure I see, because it really depends how much you kind of weight the different time factors, right? But just notice on this, right? With methane, right, tends to, over some number of generations, vastly drop off, whereas CO2 emissions are forever. On the one hand, this makes it a very difficult problem to solve without sucking CO2 out of the atmosphere at some point. On the other hand, it means that by drawing down methane emissions could have a big immediate impact, which could be extremely important, right? Drops sharply after about 10 years. Yeah. Another way to put it in graphical form, just to kind of understand these relationships, right? Okay, so we've got 3 scenarios, right? Emissions go up, emissions stay the same, emissions go down, right? So if carbon dioxide and methane emissions both go up, because the methane gets removed after a while and the carbon dioxide doesn't, carbon dioxide becomes exponentially more the factor, right? If the two are kept constant, carbon dioxide is also going to be the bigger factor. Why? Because of that longevity that it has. If you've heard before, right, that greenhouse gas emissions could stop tomorrow and the globe would keep warming for decades or even generations, this is part of it, because the carbon dioxide lasts in there and has impacts on the scale of hundreds to even thousands of years. On the other hand, if emissions were to fall, and this is the scenario that we all want, depending on any way of getting there, right? Notice that the impact of methane goes way down shortly over time, and so could be a way to drastically cut warming in the short term. Where does the methane come from? Agriculture, emissions from livestock, oil and gas, especially things like natural gas or other leaks, and including leaks from coal mines, and breakdown of materials in landfills, which emits methane. Which of those issues are the most important globally that we talked about? Sea level rise, drought, and water scarcity, right? Those are going to be the biggest issues worldwide. Why? Because these tend to lead to consequences of war, refugee crises, right? Displacement of 10 to 100 million people, which may trigger war, destabilization, mass civil unrest. Okay, this could happen in any number of ways, in any number of places, with any number of spiraling consequences, right? But where? China, India, and South Asia tend to be major flashpoints for this. We'll do the short version. There is a major nuclear flashpoint between two nations with a lot of people who are basically at risk of going to war over this contested region of Kashmir, which both of them claim as being their own. If you have a refugee crisis that spurs people to move out of India away from the coast, it could definitely exacerbate tensions here. As they say, right here in America, whiskey is for drinking and water is for fighting over. Another context you might look at for where this could turn into a giant issue is here, right? The Nile River flows up north from the south. So, engineering projects here, which might restrict the Nile River, could cause massive water resources issues in Egypt and lead to other conflicts. Notice that Gaza is right there. And that's going to do it for climate as a geopolitical issue.